What is the low frequency output resistance? So we're finding the RO in kilo ohms for the amplifier shown. We're given some values here. We can use the short circuit approach that we've discussed. Now, when we look at this, we can look at the notes linked below the like button, and on page 132, we are going to have all different kinds of circuits for here, NPNs and PNPs. Well, the circuit we're looking at now looks like a PNP. We see our Q1's going into here, and our R naught is with our VO down here. That's with our RC. So all of this is the same. It's a little bit different for these other ones, so we're going to be using the common emitter amplifier, or this can be abbreviated as CE. So now we can turn to page 138, 139, and we can find the common emitter amplifier. Now if we scroll down, we have our gain, we have our transconductance, and we have a few other things here. Now the fact that it's in transconductance is important, and we're going to come back to that in a second. So for our use, we are going to be using the equation right here. We want to be using our R naught. So we're going to take this and we can plug it into what we're going to be looking at. With this, there's a few things we can note. It starts out with our first part right here. R naught is approximately equal to our RC, which is in parallel with our R naught, 1 plus GM RE. Now remember that this is in transconductance. And because it's in transconductance, there's going to be something that happens with this R naught. So if we look here for this right here, this is our common emitter amplifier. And we scroll up a little bit, and we have transconductance right here. In transconductance, our R naught is going to be equal to infinity. So if we were to write this out right here, our R naught, it would be infinity. And when we write the parallel form for this, because the parallel form is we take 1 over our first value, RC, then we add this to 1 over our other value, which would be R naught over, or 1 R naught times the 1 plus GM times our RE. And if we plug this in, well, we know that because of transconductance, R naught is infinity. And so that this is going to be about 0. And this is raised to the -1, so after this is zeroed out, this is going to become RC, like this. So that is how that is equivalent to each other. Now that we know that, we can just say that our R naught, the output resistance, is equal to our RC. So right here, we're just going to say, and this is because of this right here. So R naught is equal to RC, which is equal to 62.9 kilo ohms. So the answer for this problem would be 62.9, and this is in kilo ohms. Now, if we were just to do it this way and leave it like this, it would be incorrect. And the reason why this would be incorrect is because we make an assumption right here, but we don't have anything to back this assumption. So instead of doing this, we need to make the formula, the equation above it, the one we're going to use, which is R naught is approximately our RC, which is in parallel with our R naught, and then in parentheses a 1 plus our GM times our RE. Now there are some things that we're going to need to find here. We need to use Ohm's law here, and Ohm's law is voltage over current to get our resistance, and our voltage here is going to be VA divided by our IC. And so that's going to give us a value of 10 volts divided by our 472 microamps. And micro is just 10 to the -6. That'll come back in a second. But next, let's look at our GM here. The GM is also pretty important. GM, and we've looked at this previously, is equal to our I naught over our V input right here. And this is going to be, for our equation here, our IC over our VT. So what we're going to be plugging in here is 472 microamps over our 26 milliamps. So now we can go back into our equation and solve for this. Our R naught is going to be approximately, and we're not putting it in the parallel form yet, but our RC, we have, or actually we can put it in the parallel form. So the parallel form is we'll have 1 over our RC plus 1 over all of this. And our R naught is just going to be the 10 ohms, or the 10 volts. So all of this is going to be a lot here. But R naught is what we have in green. It's going to be 10 volts divided by our 472 times 10 to the negative 6th. And then we have a multiply because we have this parentheses right here. Parentheses 1 plus our GM. And our GM here is 472 times 10 to the negative 6th divided by 26 times 10 to the negative 3. And now we have our RE, and our RE here is given to us as 0.9 times 10 cubed, and that's going to end that parenthesis, and this is all underneath 1, and this is all being raised to the negative first power, because that is how we would deal with parallel. Now there's a few things we can cancel out here. We have this 10 to the negative 6, this 10 to the negative 3, and this 3 here. So we can combine all of these, and we're not going to worry about it. From here, we are just going to rewrite this as our R naught is equivalent to our 1 over, let's plug in our RC. RC is 62.9 times 10 cubed, plus the 1 over, we have 10 over the 472, so that's going to be like this, times the parentheses of our 1 plus 472 times 0.9 divided by 26. This is all being raised to the negative first power. And there are a few things that we should mention here. Don't forget that we have a parenthesis right here as well. And when we plug this into a calculator, we are going to have 1 over parentheses here. So we have parentheses on the outside and then parentheses around this. And then we should have parentheses around here as well. So in total at the end, we're going to be left with 3 parentheses. Kind of messed me up a little bit at first, so just make sure that the parentheses are right. And from this, we are going to get that our R naught is approximately 53704, and we can have a 0.1852, and this is in ohms. Now we want it to be in kilo ohms, so we're going to multiply this by 1 kilo over 10 cubed. Now from here, because it's in kilo ohms, we are just going to move the decimal 3 places to the right if we bring this on top. And so bringing it to the right 3 places, it's going to be right here. So that means that our R naught is going to be equal to approximately 5, 3, and then we have a 7, but it's a decimal, 53 decimal 704, and then we can just round this to 19. So this is going to be the answer for our R naught in kilo ohms for this problem.